Alright guys, so I was asked about some questions on 4, I guess the Unit 4 review. Some of you have turned it in. Thank you for doing that. Some of you are still working on it. That's not a problem, okay? And if those of you who have turned it in, go ahead and resubmit after you see me do some of these problems here, okay? So on 4.3, if P of t, now remember, P of t, models the size of a population at time t greater than 0, which of the following differential equations describes linear growth and which one describes exponential? Remember, p is a function of t, so obviously that's why all of your answer selections are dp over dt. Now, which one is dependent upon time linearly? That, okay, in this situation, that will be this one, because 200 times t. Think of it like a linear function. Y is equal to mx plus b. And when we got more in depth with functions later on after Algebra 1, you remember that y is equal to f of x. So f of x, p of t. So p is a function of t, therefore we're looking for a linear representation of 200 times t. The next one will be exponential growth. So if I look at this, 200 is a constant, that means it's a horizontal line. 200p does not give me anything that's going to be exponential. Okay, so then the only and remember, since this is a function of time, it will only lead me to either 100t squared. That's going to be exponential in time. Okay, it's going to be kind of quadratic if you think about it right there. That's the very closest one you got to exponential growth. Okay, so it's 100t squared. The other one is 100p squared, but remember this is a function of time. So P of t models the size of the population at time t. So whenever I take a derivative of the original function, I get dp dt. I have to have it in terms of time. It's depending upon that. So the only thing I've got is 100t squared is my only answer for this one. Okay. Now 4.4. Okay, that's a lengthy one, but that's not too bad. If I take a look at how I did this before. If I take dz dt, that means the derivative of the function z, this is the function z right here, okay? And I take a derivative of that with respect to time, I'm going to end up doing product rule for this. But at the end of each derivative, I have either dx dt or dy dt, and then I have a dz dt, okay? So for example, I take the derivative of z, this guy, which will become this. So what's the derivative of x and y squared? If I take the derivative of that, then I have dz over dt is equal to, now whichever one I choose to take the derivative of first, it doesn't matter in product rule since it's all just sums. So if I take the derivative of x first, I'll end up with just y squared by itself, but then I'll have dx dt. Plus, now the derivative of y squared, well that comes out as 2, right? That exponent of 2 comes down, my x remains the same, I'm just left with y now, but since I took the derivative of y with respect to time, I have dy dt. Now, with that said, here, okay, I have everything I need to solve this except for x. There's an x missing here. I have x, z equal to 3, y equal to 1/2, but x equals 2 blank. Well, just solve for x by plugging in z for 3 and y to 1/2. And I believe x will equal 12. After that, you find out what dz dt is after you plug in what dx dt is, which is -2, and dy dt, which is 5, and you get a number. Okay, I forgot what the number is, but I think from here on out, the main thing is you deriving this equation correctly. Okay, last part. 4.6. 4.6 is given g of x is a differentiable equation or function, or just a differentiable function, I'm sorry. And they give you some information. G of -3 equals 2 and g prime of -3 is 7. Use the tangent line of g of x at x equals -3 to approximate g negative 2.9. Alright, so from this point, I'm going to, let's see here. I'm going to go ahead and add an extra page. So in this situation, they give you some information. They give you the slope. So g of -3, g prime -3 is 7. That's your slope. They give you a point. they give you negative 3, comma 2. Remember they said g of negative 3 equals 2? So that's a point. This is my x, this is my y. So how do we write an equation of a line? Well, we can simply write it in slope-intercept form. So remember that the slope-intercept form was y equal to mx plus b. Okay? Now, so we know in this situation that 7 is your m, because that's your slope. But what is your b? Well, you have your x and your y, so plug that in, and now that gives you a tangent line. Okay? So if done correctly, I believe y is going to equal to 7x. Okay, that's the simple part. But what's the b? If I plug in x for negative 3 and y for 2, I believe I get negative 3 times 7 is 21, so I get plus 23. And that's my tangent line. Now check the math. All I did was plug in x and y to get what b is going to be. Okay? So 7x plus 23 is now my tangent line. Now how do I find out? Let's go back real quick. Ooh, let me go back here. Let me go back. Now going back, how do I find out what this is going to be? Well, that's simple. Just plug in x as negative 2.9. Okay? Plug in x for negative 2.9 and then solve. So now g of negative 2.9, using the tangent line, I'll find out what g prime of negative 2.9 is going to be. Okay? So all I have to do is plug in that value of negative 2.9 into here, and I'm going to approximate what my point will be. And that's it. Okay? So going back, let me make sure here. So I want to find out g of negative 2.9, use a tangent line of g of x at x equals negative 3 to approximate g of negative 2.9. Okay, so once I find out once I use that, I find out exactly what my value is. So if I plug in negative 3 into here, y is equal to a certain value. If I plug in negative 2.9 to here, y is a certain value there, and that's my approximation. Okay? Hope that helps you out, guys.